And welcome. I'm your host and speaker Ananya Vaishnav, and I am Associate Data Engineer at Infometry. Thank you for taking the time to join us today. In today's webinar, I will be talking about advanced SQL technique for data analytics and performance tuning. Feel free to drop questions on the topic or share your experience during this live session. We will answer your queries through chat. Let's start the session. This session is organized by Infometry. We are pure play data analytic company based out of Fremont, California, with our offshore development center in Bangalore, India. We came into inspection back in 2010, and since then we have been offering domain-specific analytic solutions for high-tech, energy, life sciences, retail, manufacturing, and finance customers. Being a data analytic software services and solution provider, we focus on delivering predictive and prospective analytics solutions, cloud data warehouse implementation, data governance, enterprise service bus, microservices-based integration solution, big data, cloud DevOps, Salesforce CRM, and product engineering, etc. Infometry has been an engineering and consulting service partner for companies like Snowflake, Google Cloud, Informatica, MuleSoft, Databricks, Fivetran, AWS, Tableau, Adaptive Insights, Microsoft Azure, and Matillion. We expertise in cloud data warehousing, data orchestration, advanced analytics, and AI. Informatica has developed 22 plus Informatica cloud connectors and Snowflake native application with pre-built connectivity to NetSuite, Salesforce, and Marketo, enabling real-time analytics across Snowflake, Google BigQuery, Amazon Redshift, Databricks, and Azure Synapse. One mentioned under Blue Blocks are developed and owned by us, and rest all developed by us only for organizations like Informatica, SAP, Cadillus, etc. We have developed the state-of-the-art analytics solution InfoFiscus, which can be hooked to any on-prem or cloud CRM or planning apps. InfoFiscus is 100% cloud-based, pre-built analytics software developed using open architecture. InfoFiscus comes in three different flavors: finance, supply chain, and sales marketing analytics. We are delighted to announce the launch of the next generation InfoFiscus Sales Analytics Snowflake native application, which aims to streamline sales analytics for customer using Salesforce, Marketo, and Snowflake. That's our quick introduction, and now let's move to our today's agenda. Data is growing at an incredible pace, and SQL plays a critical role in managing and retrieving that data efficiently. But as data set expand, performance challenges arise. Slow queries can affect everything from system performance to overall productivity. That's why optimizing SQL queries is so important. SQL performance tuning helps queries run faster, use fewer resources, and streamline data processing. In this session, we will explore advanced SQL techniques that go beyond just writing queries. You will learn how to identify bottlenecks, optimize joins and aggregation, leverage indexing, and analyze execution plan to improve performance. By the end, you will have practical strategies to make your queries more efficient and get the most out of your database. Introduction to SQL Performance Tuning. Now that we have set the stage, let's dive into the SQL performance tuning. When dealing with large datasets, query efficiency is key. Slow queries don't just waste time, they consume system resource and impact business operations. Performance tuning helps reduce execution time, lower CPU and memory usage, and improve overall data processing efficiency. Today, I will walk you through practical ways to fine tune your queries. We will cover indexing strategies, query optimization technique, and execution plan to help you writing high performance SQL queries. Why performance tuning is important? Optimizing SQL queries isn't just about making them work, it's about making them work efficiently. Poorly optimized query can slow down data retrieval, cause delay, and impact productivity and even drive up cost. Performance tuning helps ensure that your queries run faster, use fewer resources, and data more efficiently. The result: quicker execution time, lower CPU and memory usage, the smoother input-output operation, ultimately leading to faster, more valuable insight from your data. Next, we have key performance indicators for SQL queries. When running SQL queries, it's essential to understand the key performance indicator, also called KPIs, that determine how efficiently a query runs. This indicator helps us measure and analyze query performance so we can pinpoint areas for optimization. The first and most important KPI is execution time. Simply put, this is the amount of time it takes for a query to complete. The longer a query runs, the more system resources it consumes. Optimizing execution time directly leads to better database performance. Some ways to improve execution time include indexing, query rewriting, and avoiding unnecessary computation. Next, we have CPU usage. If your query consumes too much CPU power, it can slow down the entire database system, especially in shared environment. High CPU usage is often caused by inefficient join, excessive sorting, or a lack of proper indexing. By analyzing CPU usage, we can determine if the query is too complex and find ways to simplify it. Memory usage is another crucial factor when queries fetch large data sets. They can use a significant amount of RAM. If a query relies too much on memory, it can cause performance bottleneck. Using indexing, partitioning, and limiting result sets can help reduce memory consumption. Input-output operations, such as disk reads and writes, are another key metric. If a query frequently scans large amount of data from a disk, it may indicate missing indexes or an inefficient query design. Ideally, we want to minimize disk input-output by retrieving only the necessary data. Using select statement wisely and avoiding select star can significantly improve input-output operation. And the next, we have common SQL performance issue. Poorly indexed table. One of the biggest culprits behind slow queries is missing or poorly designed index. Without indexes, the database must scan entire table to retrieve results, which can extremely slow, especially for large datasets. Proper indexing ensures that queries fetch only the necessary record in an efficient manner. Missing statistics. SQL query optimizer rely on a table statistic to determine the more efficient execution plan. If statistics are missing or outdated, the optimizer may take poor decisions, such as choosing a full table scan when an index scan would be faster. Regularly updating statistics helps maintain query efficiency. Poor complicated queries. Complex query with excessive joins, nested subqueries, or unnecessary computation can be major performance drag. Sometimes, breaking down a query into smaller, more manageable parts or using common table expression or CTEs can significantly improve efficiency. Next, we have lack of optimizations for joins. Improperly structured join can lead to massive performance hit. A common mistake is using joins without proper indexing, which can cause the database to scan large amount of data instead of efficiently retrieving relevant rows. Redundant data retrieval. One of the biggest performance issue in SQL is retrieving more data than unnecessary. Fetching unnecessary rows or columns increase memory usage, slow down query execution, and put extra load on the database. This often happens when queries aren't optimized with proper filtering or when all columns are selected instead of only the required one. To improve performance, always retrieve only the data you need by applying filter and selecting a specific column instead of using broad queries. Inefficient use of subqueries. Subqueries can be powerful, but if used inefficiently, they can slow down queries significantly. The problem arises when subqueries run multiple times for each row in a database, leading to excessive computation and resource usage. A better approach is to optimize query logic by using more efficient alternatives like joins or common table expression. This reduces redundant processing and improves overall query performance. By recognizing this common SQL performance issue, poorly indexing, missing statistics, overcomplicated queries, lack of optimization for joins, redundant data retrieval, and inefficient use of subqueries, we can take a proactive approach to optimization. Up next, we will explore some advanced SQL technique to tackle this challenge. Technique. Let's talk about some basic optimization technique that can help speed up your queries. First, indexing is crucial because it helps the SQL engine quickly locate rows. Using limit or top ensure that you retrieve only the necessary data, saving time and resources. And whenever possible, use join instead of in. Joins are usefully more efficient. As you see in this query, using select statement twice instead of use join, which can be more efficient. We could optimize it with a join as shown in the next query. Now we are going to shift the gear and look at more advanced SQL techniques. These are powerful tools that can significantly improve performance and enhance your data analytic capability. If you have ever struggled with slow query, inefficient join, or complex aggregation, this technique will help you write better, faster, and more scalable SQL. Let's take a look at what we will be covering. Query refactoring, window function, advanced join, CTE, partitioning, query execution plan. This technique may take little more effort to master, but they will bring big benefit when used correctly. First, we have window function for advanced analytics. Window function allow us to perform calculation across a set of rows that are related to the current row. They do not collapse the result set, which is useful for tasks like running total, average, or complex ranking. This is a great tool for analyzing large data set without losing individual row detail. In this example, we are calculating a running total of sales amount per region ordered by sales state. The key here is the sum and over function, which calculates the sum without collapsing the result into one row per group. Next, we have ranking function. Ranking function are another powerful tool for SQL performance and analytics. Functions like row number, rank, and dense rank help assign rank to row based on a specific order. They are especially useful when you need to assign position or rank to your data, like finding the top seller in a given period. In this example query, here we are ranking employee based on their sales amount, with the highest sales getting rank 1. This is a great tool for leaderboard style report or top performer analysis using common table expression. Common table expression are used to simplify complex query by creating temporary result set. They improve readability and maintainability of your SQL code and allow you to break down complicated logic into smaller and easier to understand pieces. In this query, the with clause defines a temporary result set with regional cells that contain the total cells for each region. We then use the CT in the main query to filter out region with total cells greater than 1 million. Next, we have partitioning large dataset. Partitioning is a technique where large tables are divided into smaller, more manageable pieces. It's called partition. This allows SQL to process smaller chunks of data at a time, which can significantly improve query performance for large datasets. Partitioning works especially well for queries that filter on a partitioned column, such as date or reason. This example shows how we can partition the sales table by sales date. This means that queries filtering by date will only scan the relevant partition. It reduces the workload. Next, we have understanding execution plan. One of the most powerful tools for diagnosing slow queries is the execution plan. The execution plan shows how the database engine processes your query, detailing things like table scan, joins, and indexes used. By analyzing this plan, you can identify performance bottlenecks. In this example query, running explain before your query gives you insight how the database will execute it. If you notice that a full table scan is being performed where an index could be used, it's time to optimize your query. Using indexing for performance tuning. Indexes are one of the most important tools for improving SQL query performance. They help SQL locate data faster by creating a lookup table that speeds up the retrieval process. However, it's important to use the right type of index and to not over-index, less excessive indexing can degrade performance. Optimizing joins. Joins can be a major cause of slow performance if not used properly. To optimize joins, always make sure to use the most selective condition first and avoid joining large table unless necessary. Remember, inner join is usually faster than left join when you don't need data from both tables. This query demonstrates an efficient inner join between customer and order table using inner join. Ensure that we only get matching record from both tables, reducing unnecessary data retrieval. Avoiding subqueries for performance. Subqueries, especially in where clause, can be slow because they require the database to execute a query for each row in the outer query. Whenever possible, replace subqueries with join statement to improve performance. Optimizing aggregation. Aggregation like sum, average, and count can slow down queries when working with large datasets. To optimize this operation, limit the column used in group by and use indexed column to speed up aggregation operation. In this example query, we are aggregating sales by product ID. This operation can be optimized by ensuring that product ID is indexed, which reduces the amount of data the database has to process. Next, we have query caching. Query caching is stored the result of a query temporarily, which helps to speed up repeated query. However, be mindful of when the data changes, as caching can cause outdated result. It's important to balance caching with real-time data accuracy. Troubleshooting and best practices. Regular monitoring and troubleshooting of queries are essential. Use tools like explain, analyze query execution time, and keep track of slow queries. Following best practice like avoiding select star and testing queries on smaller database before execution will help prevent unnecessary bottlenecks. To wrap up, remember that performance tuning is continuous process. Regularly analyze your queries, optimize joins, leverage window functions, and use indexing and partitioning to improve performance. This technique will significantly speed up your SQL queries and make your data analysis more efficient. Thank you for attending today's webinar. We have covered a lot of advanced SQL technique from window function to query execution plan and partitioning. Now, I would like to take any question you have, so feel free to ask away.
Yeah, hi Anani. I have a question. Why is indexing important and when it can negatively impact the performance?
So yeah, hi Alekia. So indexing improves query performance by reducing the number of rows scanned. So if you use too many index, it will slow down your upsert operations. So you using the proper indexing is also important. If you overuse the index, it will slow down your performance, query performance.
Okay, thank you.
Hi Ananya, this is Sagar. I have a question. How do Windows function improve performance compared to group by? Thanks.
So yeah, so window function do the functioning according to in a row-based format, while the group by function works in aggregation. So that's why window function is quite perform well in comparison to group by function.
Okay, got it. Thanks.
Hi Ananya.
Hi there.
So my question is, how when should you use table partitioning, and how does it improve the performance?
Table partition. Okay. So partitioning is basically used in a large data set. So if you have a large data set, so try using partitioning. It improves the query performance, especially for time series data, logs, and historical record.
Mhm. Yeah.
Hello, Ananya. This is Poonam. So my question is that how do execution plan helps optimize queries, and what should you look in for in such execution plans?
Okay. So execution plan reveals the whole history of a table. So
Mm-hmm.
when we use execution plan, so basic means we need to use explain function in front of our query. It will give you the overall structure of a table. So there are a few things we need to analyze on a table. So like full table scan and join type, index usage. So uh, all these key points we need to take care when we see the execution plan.
Okay. Okay, got it. Thank you, Ananya.
Thank
Yeah. Hi Ananya. Thank you so much for the amazing session on advanced SQL. I hope everyone found the session really useful and informative. Before we wrap up, if anyone has any questions, please feel free to ask. Okay. No questions. That's okay. Yeah. Thank you so much. Thank you all for joining. Have a great day.